So, welcome Dave Stetzer to the Power Couple podcast. Thanks so much for joining us. And today, this is a message that is so important. I think it's probably the most important podcast that I have done so far, and the most important message that people need to hear because it's a message that I didn't hear for so long. I thought I did, but then colleagues like Paul Harding made me even more aware of the concept and the effects of what is known as dirty electricity, also known as electromagnetic interference. And today we welcome Dave, who's a very special guest, who's going to talk about not only his story with how he got involved, also we're going to go into concepts like body voltage, what building biologists don't teach, and why fires and misconceptions around these Stetzerizer filters are just misconceptions. And then we'll talk about some of the health effects. So thank you so much, Dave, for joining us.
Thanks for having me.
Yeah. So maybe you just tell listeners a little bit about yourself, how you got started in the field of electronics, and then maybe we can talk about what happened with the building biologists and um, why this is still not considered to be an effective EMF remedy, although I know different. But yeah, maybe we can just go into your story a little bit and tell us a little bit about yourself.
Well, I was in the United States Air Force. I was an electronics technician, worked crypto, and a guy named Martin Graham, who was in the United States Navy, and he was an electronics technician also. And Graham went on to be a professor emeritus from UC Berkeley, and he has over 40 patents to his name, high-speed data, things. And he was my best friend, and I don't know, probably late 90s, right in there. Farmers were complaining all the time. They called it stray voltage, and I never did any work with stray voltage because I started my own business after I got out of the military, and we have a big electrical shop and electronics and stuff, and electrical contracting. And what happened is a lot of the farmers, they couldn't find credible people to go ahead and help them with what they call stray voltage. I always thought you could never be a UFO expert unless you took a ride on one. So how can you be a stray voltage expert when voltage doesn't stray? It doesn't. It goes where people put it. It's governed by the laws of physics. Okay, so I never got involved in it. And fast forward a little bit, I ended up getting involved in it to help a guy out, and I found the problem right away. Well, then I found that the utility was kind of like, a little crooked on this. They knew about it. And so then I started doing a little more research on it. And what we found was that the small amounts of electricity, high frequency transients, okay, affects daily milk production. And the nice part about the cows is that if we could lower that, in other words, we figured a way of measuring it, because that's why we are a measurement expert to use an oscilloscope. And we put two plates on the barn floor and we're measuring this electrical activity. Then we ask the farmer what time you get done milking in the morning. If he says 8 o'clock, we do a line at 8 o'clock. And we looked at the data. We had a computer program to manage the data written. And then we would say, okay, how many times did the cow get shocked? How much was she exposed to? And if she got exposed to a lot that day, her milk went down a lot that day. And if she got exposed to just a little bit, her milk, went down a little bit. But if she got exposed a whole lot less, her milk went up a whole lot. And it's instant. I mean, it isn't like we got to wait 2 weeks before we get a reaction. So that was kind of nice with the cows. But so that was a kind of a done deal. We built a lawsuit for the state attorney general of Michigan, Jennifer Granholm back in those days, Graham and I. And so what happened is these farmers would say, look, this doesn't just affect people. it affects, or I mean cows, it affects people. My wife comes into the barn, gets heart palpitations, passes out, and they listed these symptoms. But when they said the symptoms, Graham and I were both ex-military, and the symptoms were symptoms of radio wave sickness. Now they've been around since the end of World War II when radar was developed. And so now they've declassified them, but at the time they didn't declassify them. And so in order for us to talk about them, we had to have printed information. So I went to Ukraine, and I went to Moscow, and I went to Russia and places like that, and we got printed information. So, but what we found was the most biologically active frequencies are between 4 kilohertz and 100 kilohertz. And going back to the cows, we found it on the ground. Okay, in North America, we use a grounded wise system. In 1998, 70% of all the current that went out on the power lines returned to the substation via the earth. So you don't want to be earthing or grounding or anything in North America. But we found it on the ground. So how did it get on the ground? It came from the power company. They put it in the ground. But how did it? Power company doesn't generate it. So then we're working backwards. And so it's from modern day electronic devices. In 1972, there was an oil embargo and we had to get more energy efficient. So we started using current and voltage in a different manner. And so we started chopping up the sine wave, and it creates these high frequency transients. At the time, like Dell computers, they had this Dell Inspiron. It put like 25 kilohertz back on the line and on the ground, of course, here, but now it's really on the line to start out with. Apple computer, 12.5 kilohertz. Dell Towers, 16.6 kilohertz. So you can see the frequencies are in the most biologically active frequency area. So then we thought, well, look, if this is the case, if we can make a product or something, we didn't want to have a product to sell because we thought it took away from our credibility as experts. But just for science, if we make up something that can remove that, and if you want in science, you got to show that A causes B. If you remove A, B goes away, and you put A back, it comes back. Okay, so we did that. Okay, and we did research with the University of Wisconsin-Madison, and on chronic fatigue syndrome. Now, if you take the symptoms of chronic fatigue syndrome, no known cause, no known cure. Fibromyalgia, no known cause, no known cure. ADD, ADHD, no known cause or cure. Now I'm old, so nobody in my class or kids or anything had ADHD or ADD. But anyway, if you look at those symptoms, they're the exact same symptoms of radio wave sickness, which is a known cause, is exposure to high frequency, and a known cure. You remove the high frequency. I mean, if you go, like I spent a lot of time in Russia and Kazakhstan and Ukraine and places like that, and they have something what they call a sanitary station. It's sort of like what we would call our health department. And if you go to the doctor and you have these symptoms, instead of saying, well, you got chronic fatigue, it's radio wave sickness. And so they send somebody from their health department out to your home and to your business to find out where it's environmental, where you're being exposed to it from. So
Wow.
it's kind of.
That's amazing. That's exactly what we need here, but we're doing it ourselves. We're doing what our government isn't doing, unfortunately. But
yeah, so now you got to buy a meter, which they aren't cheap, but we had the meters, and we started with like, chronic fatigue. Okay, so we had 20 out of 20 people got better when we cleaned up the electrical environment. Now, this is about 98, 99, okay? But I have to be careful because I say cleaned up their electrical environment. We made some filters and we can put them on the wall and take the stuff off the building's wires, okay? That's all we did. But Wi-Fi was not there then. We didn't have a cell tower on every corner. we didn't, not everybody, hardly anybody had a cell phone, and if you did, it was so big you couldn't, you just left it in the dash of your truck, the flip phone, the old one. But so all we had to do was do that. Now we started getting like really astounding results. Okay. So we had chronic fatigue. That was the first thing. And then MS, people with MS, they improve. And usually there's two types of MS, I guess. I'm not a doctor, but one is progressive, I think it's called, and I can't remember the other one. But anyway, one, you get it and it's just like a slippery slide. You're going downhill, you get worse, 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 worse all the time. The other one, you go down, you hit a plateau, and you come over, and then you go down again, and you hit a plateau, and then you're down, down, down. But you never go the other way. So what happened is when we put them in people with, supposedly had MS or diagnosed with MS, it went the other way. Now, it wasn't just us that did the research. All we really did, research was done independently by Professor Magda Havas, who was a professor in from Trent University of Environmental Sciences in Canada, Professor of Medicine Samuel Milham, who uh, was the health department head of the health department in Washington State. There was, Yuri Grigoriev, who was a grandfather of electromagnetic radiation in Russia. We did all kinds of, help with them. Basically, all we did is make placebos and things like that for the. And so then we started saying, okay, look, if you have a headache, you can noticeably see the difference. We put filters in a school. We cleaned up the environment in a school. The school was being sued. The school board was being sued for unsafe building conditions, okay, working conditions by the teachers union. And so what we put filters in, but they had done the mold thing and they did the formaldehyde thing and all that stuff before. Nothing really worked. Put the filters in and boom, it all went away, their problems. And 37 kids had asthma in those buildings, were taking inhalers and they quit.
Wow.
So yeah, so you have an allergic reaction to this stuff, so your body produces histamine. So we had very good success, with this. But then, like things like the chronic fatigue and fibromyalgia, it's not a number. So if we look at the number on the wall and we look at, like our meter, we reduce it to a certain amount. And then what do we plot it against? If you have a headache and your headache goes away, only you know you had the headache. We can't prove it. But then there was things like blood sugar. Okay, that's a number. And I always say, well, maybe the Dalai Lama can change his blood sugar psychosomatically, but I can't. Okay. So blood sugar is a number. And so Professor Havas did some research there and found that nobody had less than a 92% reduction or 52% reduction in insulin usage. So it went from 52 to 92%, just in insulin usage at type 1. Milham did some research on neurotransmitters, collected people in Olympia, Washington libraries, urine for 12 weeks, checked the neurotransmitters. That's the electrical grid of your immune system. So you don't want to have any coming out. And nobody had less than 300 coming out of their body. And so we put those filters in or cleaned up their environment. And that's all we did, put the filter in because the Wi-Fi and stuff was still there. But we put the filters in and it collected their urine. So within 8 hours, we have to say, because there's 2 shifts. We don't know when they collected it, beginning. But within 8 hours, nobody had more than 3 neurotransmitters in their urine for the next 12 weeks. So that's a number that's plotted against the number. And so this is it's an engineering solution to an engineering problem. This stuff is on the building's wires for modern day electronics. ADD, nobody had ADD, but we didn't have, we had vacuum tubes when I was a kid.
Mm-hmm. Well, it reminds me of anxiety, how that came about. And then when the telegraph was invented and everybody started having anxiety all of a sudden, right? That was never a big thing in the 1800s, right? So maybe, so yeah, thanks for all that, Dave. I'd like readers or sorry, listeners, I should say, to know also why some people think or they'll say this is a scam, the filters don't work, they cause fires. And maybe you can go into what happened with the building biologists and uh, why to this day some people, there's a big question mark on these filters. Now, I'll just preface this and say that these filters are UL listed. That's Underwriters Laboratories. So they're already fire resistant. But I'll let you kind of fill in the blanks there. But I'd love to hear that story again with the building biologists and what happened with Mercola and the picoscope.
Well, yeah, what happened is the building biologist, they use a picoscope. It costs $300 or something like that, and you hook it to your computer. But it runs on DC power, which, all electronic equipment does. So we have to take the AC and turn it to DC. So it's a switch mode power supply and it chops up the sine wave, right? Where if you take like an oscilloscope like Fluke makes or Textronics or something like that, yes, you can plug it into AC, but it's also battery power. Okay. And so you can run it on battery. You're not going to get that influence. So what picoscope, there were some guys from building biology and said, oh, we're doing work with Stetzer filters that makes the sine wave look worse, right? And they captured the waveform and stuff. Well, it doesn't. And it's crap. I mean, first of all, we're measurement experts here. And Graham certainly is, and to have 40 patents to his name. And so, and I'm a senior member in the Institute of Electrical and Electronic Engineers. And so our scopes don't show it. I don't have a picoscope and I'm gonna. So anyway, Dr. Mercola, I run into him, I think in New Jersey or someplace. But anyway, we were talking, and then he actually bought a Fluke oscilloscope, and he knows how to use it. He's a very smart man, and so we showed him how to use it, and then he had some questions, and then he had a building biologist at his house, and he did all kinds of work. And it cost him a lot of money, and then uh, he didn't get any better. He was sick, and he called me in my house, and I said, "Look, did he ground it? I mean, they painted the wall. It cost them a lot of money. So basically, he painted the wall and hooked it to the ground. Well, basically, what he did then is the ground has a lot of this crap in it. I mean, it's really bad, okay, in North America. So now you got this great big metallic wall, right? And you hook it to this basically like a live wire with high frequency on it. So now you got like a big satellite dish and you're going to sleep in front of it, right? So that's why I didn't. So I said, well, just unhook the ground. And he did, and it was good. So now it's like, okay, so now he kind of started dropping off the building biologist thing. So he said, look, uh, and they're trying to say these filters are no good, but when Cole will put them in himself and he feels great, right? So it's like, you guys are screwed up here, And so you either go up, he was on their board. You see, you either take a bunch of people and you go up to Stetzer's and, and he made arrangements. He said, or I'm going to, destroy you guys. So they come up here and there was 3 or 4 of them. And, they had their picoscope and you could show them that it's the picoscope that's making it look that way. Had nothing to do with the filter. The filter didn't do anything, to crap it up. It was their picoscope. And so then, of course, they didn't want to admit it. And the other thing too is we did this so people could get better. Okay. So we don't have a very high margin here. And so if they're buying a filter for 300 and selling for 1,200, like a whole house filter, they're making, $900. If they're buying a box of our filters and they're only making $5 on it, they would have made $100, right? So, but we did it so people could get better. And I'm sorry they cost that much, but we had to get them made, and with tariffs and duty and all that stuff, it kind of the price gets driven up, and plastics and everything else. Now, as far as the fire goes, there's never been a fire, but they're UL approved in Underwriters Laboratory goes ahead and they test for fires. If you take a torch, okay, a regular torch, and you hold it on the filter and you hold it on there long enough, it's going to burst into flames. You're going to get a flame right where the torch is. Now, if you remove the torch, the flame will go out instantly. Okay, so not burning. There's a guy named Jay Bartell, Jay Bartell. And if you go on the internet and you type in Jay Bartell and then type the word extortion behind it, you'll find that that's where this fire thing came from. He sent me an email or a text and he said, if you don't give me $2.2 million by 4 p.m. on July 4th, I'm going to put this thing on the internet. And he has a little thing where some people, right? And so then he called me and said, what are you going to do about it? And I said, well, you need to look up the definition of extortion. So he sued me for $3.3 million for defamation of character. But the judge said, look, you are an extortionist. I don't care if he called you an extortionist or not. You are an extortionist. You've been tried for extortion before. You've been charged with extortion, been convicted of extortion, whatever. If you're a plumber and somebody calls you a plumber, you can't sue him for calling you a plumber. So, and he makes a living that way. You won't find just my name on there. You'll find all kinds, dozens of people who had dealings with him. So that's how he made his money. So that's the fire thing. But there's no fire. I mean, if somebody wants to try it, take a torch, put it on there, then send me the burnt up one, and I'll send you a new one.
Yeah, and Dave's team and Dave himself will answer the phone sometimes, and they stand behind their products or support. You actually get a human being, which in this day and age, most of us like. I don't know, maybe some people don't like that. They like, listen, I'm all about efficiency when it comes to emailing, but when you're in trouble, it's great to have that human voice, and that's as close as and quick as the service I've ever gotten. And that's not just because I'm interviewing Dave and talking about his products. It's the truth. You can try it out yourself. um, but yeah, so maybe we can talk about, just for people to understand how the technology works, because um, to give some background, I got really interested in the whole field of building biology, which not only focuses on electromagnetics, but also different aspects of water, uh, and how our homes work. But what fascinated me was the whole body voltage test. I said, oh, okay, this is cool. I've never heard of this. But then I found out that there's a lot to be desired with that test, and how to take a real body voltage measurement, or I should say an electrical measure of electrical current through our bodies, is a little different. So maybe you can tell listeners how the technology works with inductance and capacitance, and what conductance and capacitance is, maybe just put it simply, and how that relates to body voltage, and or how our bodies work, how to take the right kind of measurement of our electrical current in the bedroom, if you can. And I know that's asking a lot, but maybe you can touch on some of those.
First of all, we live in North America. And like I said, in 1998, 70% of all the current that went out on the power lines returns via the earth. Okay. So connecting yourself to the earth is like connecting yourself to a live wire. Okay. So now, if you took two screwdrivers and you went out into the yard, right, and you put one and you go 10 feet away, you'll get and take a voltmeter and go between them with a wire, right? You're going to get a reading. Now, where did that voltage come from? Actually, from the power company, and right? I mean, it has nothing to do with you or your body. All right. So now, if you hook onto the ground plug in your house, right? It's the same as it goes out to a ground rod and it's going out to the center tap of the transformer, and it's also going to the primary neutral on the electric utility line, right? So anyway, if you hook on there and then you go over and you take a voltmeter with a wire and you hold it in your hand and then it goes down through you, basically what you're doing is you're the second screwdriver, okay? Your body. So it has nothing to do with you generating an AC sine wave or an AC voltage, your body does not generate that. Okay. Your body runs on DC power. Okay. I mean, your nerves and all that is DC. And we actually got this little device that we made. We call it your inner voice. And you can take and squeeze your hand, you'll hear, and you could go up on your tiptoes and you'll hear like a rushing water, But then if you're standing somewhere and we say, okay, and somebody goes and varies a dimmer switch in the kitchen, you'll hear going through your body. But that's actually an EKG patch put on your wrist and on your ankle, so we can actually hear it. But your body runs on DC. We don't want AC in it. The body voltage meter, it's like nothing. It's a scam. And you can say, okay, I put this mat down, for example, and I'm working on my computer. My body voltage is 50 millivolts, and now I put this mat down, and now I touch my computer, and it goes down to 20. So therefore, I should be on this mat. No, you don't want to be on the mat. If you take your water faucet in your house, okay, and your kitchen sink, and if you could tee off and you put a pressure gauge there, it might be 80 pounds per square inch, right? So that's the water pressure, right? So voltage is like pressure. Current is like the flow of water. So now if you turn the faucet on, the pressure is going to drop. You understand? But the current actually increased. So now here you are on this mat or something, and you're working on your computer. You actually got more current flowing through you. Your body voltage looks like it went down. Yeah, the voltage, your current is increased, but the pressure isn't there anymore because you gave it a path. So the body voltage thing it's crap. Now, is there current in your body? Yes. What happens is your body, and you can look it up, it's called the Underwriters Laboratory, or UL, 5-component model of the human body. You'll look at 3 resistors and 2 capacitors. What is a capacitor? First of all, it holds a charge. Secondly, it's a short to high frequency. Okay. So if you get above 2 kilohertz, that energy, those capacitors short, and all the energy dissipates internal to the human body. Okay. Now, if you're working under fluorescent lighting all day, work in front of a computer, whatever, you'll actually start to build up a charge. Okay. So now you have inductance, you have capacitance, okay, and you have resistance in your body. What happens is the electrons in your body start oscillating back and forth. And if you go back to your 7th grade science or whatever it is, where you had the periodic table, okay, remember the atom, the protons, neutrons, electrons, okay? Electrons are negatively charged particles. So, okay, so they move over to one side of your body. So they go over to the left side. The problem is too many of them move over. So now you have holes in the atom on the other side. So now they move back again. And so then, but the problem is too many of them move back. So it oscillates back and forth. And so you actually have a charge. And when it's oscillating back and forth, the field builds up and we can measure it. Expensive meters, but we can measure it. Now, if you stand on a piece of aluminum foil, okay, just cheap, right out of the cupboard aluminum foil, shiny side up, shiny side down, it's like taking 2 capacitor leads and touching them together. What happens is the same amount of electrons get on one side of your body as the other. It's like, now there's nothing to attract them, nothing. So you lose your charge. So you can discharge. Is it good to discharge? Absolutely. But you don't have to pay $150 for a grounding mat or earthing mat. Just stand on a piece of aluminum foil.
Wow.
And,
So sorry, David, to interrupt you. How long would you stand on it?
oh, okay, that's a good question. And I don't know I know the answer, but when we were in Russia, we did research on this, and we would take these girls they work. They're women. I call them girls because I'm old, but anyway, they would work from 9 o'clock in the morning or more until like 8 o'clock at night, right? And they would be like 32 volts per meter when they would leave. They would still be at 27 volts per meter when they come to work. Now, we would stand on a piece of aluminum foil. Now, if you're heavier, okay, you discharge faster. And if you're thinner, more petite, you discharge slower, or So, but if you stand on it for a minute, everybody's going to be discharged. So, if worst case scenario, I don't know, stand on it for a minute, and you're totally discharged.
Gotcha. Now, is that something you do daily, or is it something that you would tell people?
Depends on what I'm doing. My
Hmm.
wife does quite a bit, but it depends on where I was. If I'm in an airport flying and stuff, when I get to, I got to do it. Yeah, I'll do it. Hotels, things like that. But here in my office, I've made some special lights. We're measurement experts, so you can measure the current going through a person's body, but you need a fluke 189 or fluke 187. Now they don't make them anymore, but you can get them on eBay or something, or a fluke 287 and a fluke 289 because they have the bandwidth. Okay, you can't just take a regular meter, but you could take it and put it in microamps, put an EKG patch on your chest, clip one lead there and the other to a reference, ground. Okay. And then you can actually measure the current. Now, if you're sitting under fluorescent light, you'll see a reading. If you lift it up your hand, you'll see it go up higher. So you know what's the light. Have somebody turn the light off. Goes away, right? I'm sitting in front of a Mac computer right now. Puts 27 microamps through my body. Okay. 18 microamps that cause, uh, you know, cancer in numerous well-programmed studies. 60 microamps to stop the dog's heart, 80 will stop a human heart. So it really does mean something, those numbers. So you will build up a charge, stand on aluminum foil, will discharge. But do I do it? Yeah, sure, absolutely.
Oh.
Especially when I don't feel good.
And what would you use as the ground, the reference to ground if you're doing that EKG example?
Oh, I just plug it into the outlet here. Because
Oh,
see,
okay.
everything coming from that light is wanting to go back to ground. Ground is in North America. People think ground is like a sponge. So if you drop water on a sponge, we never see it anymore, right? Ground in North America is like dropping water on a brick. You got the water to deal with, okay? The filters, like when, how they work is we have the crap's on the neutral or if it's on the phase wire. We short it across. It's almost like sticking a paper clip in the outlet, okay? Boom, you're going to blow the breaker. But what if we could put a paper clip in the outlet, but only for the high frequency stuff? See, that's what the filter does. So you still got the 60 cycle because you need that to run your computer or your lights or whatever. So it shorts it out, but they're always 180 degrees out of phase with each other. Now, other people come along and say, well, I got a better mousetrap. I put it to ground. You just introduced frequencies because the ground, nothing's out of phase with the ground. See, we can take two wires that are 180 degrees out of phase and boom, we can short that stuff out. So if you have a 50 millivolt transient going in the positive direction and we put it over in the other wire, we just made it into a negative 50. So what's plus 50 and minus 50?
Zero.
Right, exactly. So the filters are an engineering solution to an engineering problem. That's the way it is. And the results are measurable. Okay, it isn't like here's my Q-link necklace or my bracelet, and
Mhm.
and I
Mhm.
wear a St. Christopher medal. My grandmother gave it to me, right? When I was 12. Now, if you and I went out into the street and we stood in front of a Greyhound bus, we're both going to be at the pearly gates at the same time. So
Right.
there's mystical power there and like that. So these necklaces, bracelets, things like that that you buy, that supposedly do something. First of all, where's the battery? If you want something to do some work, you got to have a power supply. There's no power supply there. You know,
Mhm.
it's a scam. And show me on a meter. I always tell people, I'll be your best disciple if you show me your nail holes. Okay. Show me on a meter.
Right. Right. Yeah. And a lot of people I know, some of my past students of our EMF course, I've taught them too that, a lot of they'll measure the field with, say, shungite, but they may be measuring the wrong field. They're measuring an electric field, volts per meter, but that's not measuring necessarily radio frequency, which is a cell phone. So People need to know. I think it's a good intention, but people also need to know how to measure, where to measure, and what meters are working. And that's why I really love the Stetzerizer filters and the meters, because they actually work. They give a precise measurement for what you're measuring, and you know what you're measuring. Whereas an all-in-one EMF meter, people get lost. So I think this is a very actionable step that, regardless if you have a cell phone or use Wi-Fi or Bluetooth, we're all, most of us, I would say, are using electricity. So this is something everybody can do, and it's honestly it's not super expensive. Some of these EMF meters out there are in the hundreds and hundreds of thousands of dollars, and this is a one-time thing. You buy it, and then and then you can take it with you anywhere you go. Um, so it's just something practical we can all do. Um, and Dave, I just wanted to touch on one last thing. Uh, on the You mentioned non-Hodgkin's lymphoma, and we're talking about kilohertz frequencies. So for listeners, just so you know, our bodies, we operate at a very low level, and our home wiring operates around 60 hertz in North America, 60 cycles per second. So 1 kilohertz is 1000 hertz. So that's, now you're amplifying something, and biologically active, say 4 kilohertz, is 4000 hertz. So we're taking something that our bodies and homes usually communicate at very low levels, like say 60 kilohertz, and amplifying that by hundreds and hundreds and then thousands of times. So do you remember what the kilohertz frequency was bioactive for in that non-Hodgkin's lymphoma?
Yeah, 25.
25. So that's 25,000 hertz.
Yes.
Yeah. Wow.
But see, the Russians made weapons with it, okay? And everybody's saying, oh, they pulse the U.S. Embassy. It's called Project Pandora, so you can look that up if you want. And so I met these guys that actually were working on that, okay? And so they didn't want to help me at first when I got there, but when I showed them with an oscilloscope what was on their building's wires, they freaked out. It's like, oh my God, because that's the same frequencies they use, okay? Now, you've heard of Havana syndrome, or ringing in the ears and all that. If you got this tinnitus or tinnitus, depends if you're Canada or US, so I'm not sure which one. Ringing in your ears, okay? So you got the ringing in your ears. I'll find 50 kilohertz, okay? Now the
Sorry,
bad part.
Sorry, say that again. You're 50 kilohertz.
Yeah, 50 kilohertz will cause ringing in the ears, or that, like they call it Havana syndrome or something. Now, with the rollout of smart meters, that switch mode power supply in that smart meter is 50 kilohertz. So our phone gets ringing off the hook here, for people with ringing in the ears. So with 50 kilohertz.
Wow. Oh, you're breaking up. Yeah, I've gotten a lot more comments with what's happening with tinnitus and people calling in with that. And people think that it's related to Wi-Fi, and it may be, but what people forget about are those kilohertz frequencies. Yeah, so thank you, Dave, for clarifying that.
Back.
Oh, hey, Dave, sorry, I don't know. That was weird.
Yeah, lost you.
Yeah, I lost you on it must have been me because it just went out. Hopefully I got the, oh man. All right. Well, we need
Yeah,
to,
a lot of people about tinnitus.
yeah, with tinnitus, a lot. It's accelerating. And they think it's the Bluetooth or the Wi-Fi, but not necessarily, right? They forget about the kilohertz frequencies.
But they go and look at your smart meter. It's 50 kilohertz. They'll do that.
Mm.
Like 5 kilohertz will be like, upset stomach and, like belching and all that. And it really is, and now like solar, that puts 20 kilohertz back on the line.
Mm.
Wind will put 50 and 20 back on the line. Compact fluorescent lights put between 50 and 100. LEDs we'll put 62.5 kilohertz and 31.5 back on the line. So you see, it's all the stuff we have is in this most biologically active range, you know.
Hmm. And can you also, do you know about is there a difference if you get a radio frequency smart meter or a power line communications smart meter that's not, RF, not wireless? Are they both putting in in on average, are they both putting 50 kilohertz back on the line?
Switchable power supply. Both of them have a switchable power supply. So both of them put 50 kilohertz back on the line. Now, the filters will take out, they start working at, 1.7 kilohertz. So that's going to take out that 50 kilohertz. So,
Nice.
yeah. We didn't just say, hey, look, let's make this thing. We needed to know what do we need to take out? So that's why I went to Russia. They're telling me you got to take out between 4 kilohertz and 100 kilohertz. Anything above 2 kilohertz is going internal. So we did all the engineering. We did all the research on it. We did all the stuff. We found it, first of all, before anything. Now, all these other people, the static and the green waves and all that stuff are all Graham Stetzer wannabes, really. And like a guy calls me up and he's a headhunter. He finds people jobs. He doesn't know electron from a ground rod. So he says, "Yeah, I want to sell your filters. Can you come out and help me and give me, like some classes and stuff because I have these people." So I went out there. He buys a box, goes to China and knocks them apart and tries to make a filter. Then our meter is what Graham and I both used an oscilloscope. Okay. And so you got to see the waveform and you want to look at the frequency. There's something called Planck's law. Energy is proportionate to frequency. Okay. So the higher the frequency, the more energy we got there. So we have to look and we got to look at the amplitude of what's there. We take out the 60 cycle, right? And then we say what's left over. And now we want to measure that and we want to calculate that energy. And if it's a high frequency, it can be very low amplitude, but it could be high frequency. You got a lot of energy there. You got a problem. So we made this meter and we developed it, the circuitry and everything. So it's basically a poor man's oscilloscope. Okay. And what, $125 or something like that. Where I'm looking at $5,000 scopes. So now this guy goes ahead and he doesn't have a meter. So actually, and we have a patent on the meter. So now he buys a case and he takes our circuit boards out. He puts them in there. Well, then we said, hey, you can't be doing that. It said Stetzerizer right on the circuit board, So, but okay, now he's measuring amplitude, okay, because he can't use our circuit, right? So he kind of using half of it, but he's only measuring the amplitude. The amplitude could be, say, 40. So he's saying, okay, you're safe at 40. But it could really be 30, the amplitude. At 10 kilohertz, you got a problem. It's going into, so it isn't that way. You have to look at it like that. I don't want to get too technical, but it's like the meter measures, it really is measuring something. No research has been done on any other filter than ours. Okay. I mean, the results are published in peer-reviewed medical journals.
Yeah, and just to recap for listeners, amplitude is the height of the wave versus frequency, which is how often those waves are coming. So if you're on the beach and you get slammed by a bigger wave, okay, you got a chance to recover. But if you're on the beach and you got all these little annoying waves constantly coming and bashing you down and trying to suck you in, even though they're a lower height, they're still bashing your body more. So that's why the frequency, it's everything, and understanding these concepts. So thank you, Dave, for extrapolating that for us. So yeah, in closing, I guess maybe tell listeners if there's anything else also you want to say, but also where they can find you and how we can support you.
Well, you can go to StetzerElectric.com and our phone numbers and contact information should be there. And like you said earlier, like I've been in business 50 years. Okay. I don't like calling and talking to machines. So you're going to get a real person. So if nobody answers, either we're closed or everybody's on the line. Okay. But just call, and if you need me, I'll talk to you. I might be on the other line or someplace, but you leave a message with a real person, they'll give me, and I return all my calls. So it's like, and there's people here that are qualified, and there's no such thing as a dumb question. I'd rather answer the dumb question than fix the stupid mistake. You know, like, okay, I mean, that's what we're here for. If we don't like doing it, then we'll go ahead and get a different job.
Mhm. Okay, and yeah, for everybody listening, if you want to jot the phone number down, it's actually area code 608-989-2571. And the website is stetzerelectric.com, all one word. So thank you so much, Dave, for everything you're doing. Again, listeners, I encourage you to go to the website, grab some meters, because this is something we can all do, regardless of our cell phone, or even expensive shielding solutions that may or may not work. Go and grab some filters now, because you will feel the difference. I can say I felt the difference in my kitchen, both mentally and physically, and I knew it was working because my fridge actually got quieter. I can't stand that fridge. I'm very grateful to have it, very grateful to have it, but it got quieter. So anyway, thank you so much for everything you're doing again, and thank you, listeners, for supporting the podcast and your time today.